So we're going to be learning about C++. But the first thing is you have to learn what it is. And then we're going to dive on into our Hello World application to make sure that we have everything installed after setting up our integrated development environment, our tool chain, and our compiler. So C++ is a high-level, general-purpose programming language. It was created in 1985 as an extension of the C language. It introduces object-oriented programming features, allowing for more organized and modular code. C++ is widely used in developing operating systems, game engines, embedded systems, and high-performance applications due to its efficiency and flexibility. So C++ has features extended from the C programming language, and these features allow it to be object-oriented. But what is object-oriented programming? Well, it's a programming paradigm that structures software design around objects, which are instances of classes. These objects encapsulate data and the functions that operate on the data. Key principles of object-oriented programming include encapsulation, which is bundling data with the methods that operate on it. Inheritance, which is creating new classes from existing ones. Promoting code reuse. And polymorphism, which is allowing objects to be treated as instances of their parent classes, enabling flexibility and abstraction for hiding complex implementation details and showing only the necessary features. So object-oriented programming facilitates code maintenance, scalability, and collaboration in software development. Since this course has an emphasis on cybersecurity, we also have to know what is secure software development. So secure software development involves integrating security practices throughout the software development process to protect applications from vulnerabilities and threats. This proactive approach includes threat modeling for identifying potential security risks during the design phase, secure coding practices for writing code that adheres to security standards and preventing common vulnerabilities, regular security testing for conducting tests like static and dynamic analysis to detect and fix security issues, and then security training for educating developers about secure coding and emerging threats. So implementing these practices will help you build out software that can withstand malicious attacks. And that leads us into what is the secure software development lifecycle. So the secure software development lifecycle, or the SSDLC, is a framework that embeds security considerations into every phase of the software development lifecycle. The phases include things like requirements gathering, where you're defining security requirements alongside functional ones. Your design, where you're incorporating security architectures and threat models, and then your implementation, where you're applying secure coding standards during development. Your testing, where you're performing security testing to identify and mitigate vulnerabilities. And then deployment, where you're ensuring secure configurations and monitoring in the production environments. In your maintenance phase, you're regularly updating and patching software to address new security issues. So the SSDLC ensures that security is not an afterthought, but a continuous process throughout the software development. Now we got to talk about your development environment and your tool chain. So we're going to be using MySys2, MinGW, and UCRT. Your MySys2 is a software distribution and building platform for Windows, providing a Unix-like environment with a package management system, and it facilitates the development and building of native Windows applications. You also have MinGW, in this case W64, which is an advancement of the original one, which is minimalist GNU for Windows. And it offers a complete open source programming toolset for Windows, including support for 64-bit applications. Your UCRT64 Toolchain is a specific environment within your MySys2 that uses the Universal C runtime provided by Microsoft, and it allows compatibility with modern Windows applications and libraries. So together, you have a complete tool set for developing and compiling Windows applications using GCC and other GNU tools. Now we referenced GCC. Well, GCC is the GNU compiler, and it's an open source suite of compilers supporting various programming languages, including C and C++. It also supports Fortran, and initially developed for the GNU operating system, GCC has become the standard compiler on many Unix-like systems. It transforms source code into executable programs and offers features like optimization, debugging, and cross-compilation. Now, we know what our toolchain is, our compiler, and we know a little bit about the C++ programming language, but we also need to figure out how we can dive on in and start writing code for it. In our case, we're going to be using several IDEs. But what is an IDE? And when I say VS Code, what am I talking about? Well, an integrated development environment is a software application that provides comprehensive facilities to programmers for software development. And it typically includes your source code editor for writing and editing code, your compiler and your interpreter to translate code into executable programs, your debugger for testing and debugging your code, and build automation tools to automate common tasks. So, Visual Studio Code, or VS Code, is a lightweight, open source code editor, and it's developed by Microsoft. While not a fully fledged IDE out of the box, it does support extensions that add IDE-like features such as debugging, version control, and intelligent code completion. So next, we're going to be showing a demonstration video of installing and setting up Visual Studio Code and getting MySys2 and your compiler and your tool chain and all that sorted out, as well as setting your environment variable for GCC. Now, just for funsies, we're also going to be setting up and building our Hello World application within Linux. I'm going to be demonstrating using Kali Linux for this specific video. We're also going to create a makefile so I can demonstrate the contrast to using VS Code for everything on Windows and doing things in a more minimalistic way on a Linux distribution.